Alright, angles of elevation and depression notes. So when looking up at an object, the angle of elevation is formed by observer's line of sight and a horizontal line. Alright, so out to the side here they show you an example of this, or what an angle of elevation would look like. So say angle of elevation is formed by your line of sight for what you're looking at, and also whatever your vertical sight line would be. That will create your angle of elevation. I'm not vertical, your horizontal sight line, excuse me. I said that wrong. Those two lines will create your angle of elevation of whatever you're looking at. Or whatever anything is looking at. It don't have to necessarily be a person. Yeah. This first actual drawing right here is actually the drawing that's going to work for our first scenario right here. So I'm going to duplicate it down here. I'm not going to draw the stuff as well, obviously, but I'm going to just duplicate down here. So it says draw and label a diagram, then solve for missing part, round to the nearest tenth. The first one says KC sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. If KC is 6 feet tall, how far is he standing from the base of the lighthouse? So this scenario needs to be drawn out. Once again, it's the same scenario that's right here, so you can kind of see it. Obviously my drawing ain't gonna be nowhere near like that. I'm doing a stick figure. This little casing right here. This is line of sight to the lighthouse. This is looking at the top of the lighthouse. Drop that down. My little lighthouse over here. So his angle of elevation is 58 degrees, so 58 goes here. Other thing they told you the lighthouse was 84 feet tall. So you know how tall the lighthouse is itself. We should move that out some. No, that's fine. I'll keep it there. The lighthouse is 84 feet tall. They also told you that Casey was 6 feet tall. That's important. This is one of the main things y'all need to see on what we're about to do right now. How you need to make adjustments. So Casey's 6 feet tall. And then they want to know how far from the lighthouse is he standing. So they want to know his horizontal distance right here, X. Adjustments need to be made though. I can't just work with these numbers right here. It's good to know that the lighthouse is 84 feet tall, but from the triangle that I formed based on my drawing, I don't need to know the whole height of the lighthouse. I need to know this length from here to here. One, tell me something smart. I need to know this distance. Huh? Jamal, go ahead. Yes, subtract 84 from 6 so I can get this length from how tall he is to the top of the lighthouse. Which is what? 74? 70 what? 78, my bad. So 78 feet is what I need to use here. Alright. So now that I made that adjustment, I can label. Yeah, now we just label them like we had before. Hypotenuse here. Opposite here. Adjacent here. What trig function am I using? Tan of 58 degrees equals opposite over adjacent, so 78 over x. Then from there, solving for x, multiply by x. My x cancels. Somebody got a number for me already? That sounds good. 48.7 feet. So that was how you would solve this figure, see how far he is away from the lighthouse. Like I said, a lot of this you're just going to be able to imagine the situation and draw it out. We're going to do a couple more. You should start to click so you got the while. The angle of elevation from a kicker's foot on a football field to the top of a goalpost bars is 17 degrees. If he's standing 131 feet from the base of the goalpost, how tall is the goalpost? Alright, drawing that scenario up. Y'all can just make the triangles. I'm just making people just, I don't know. I'll be having fun doing it. I don't know why. That's my kicker with his foot. That's the ball. Triangle. So, angle was 17 degrees. Angle of elevation. It said he's standing 131 feet from the base of the goalpost. So his distance from the goalpost is 131 feet. That should be here at the bottom. And they say how tall is the goalpost? X should be here. Once you draw it out right, you should be able to label correctly. H-O-A. I was telling them last class, a lot of these will be tan, but not all of them will be tan. Tan is a popular way to write word problems for some reason. But this one is tan. Tan of 17 degrees equals X over 131. Times 131 times 131. That's not a degrees. Yep. If you check in, make sure you see 40.1 in your calculator. Sliding on. Leah's mom is standing at the bottom of a slide at a playground. So imagine that scenario. Lady standing at the bottom of a slide waiting on a little child to slide down. Waiting on Leah to slide. If the angle of elevation from the bottom of the slide to the top is 46 degrees and the slide has a height of 9 feet, what is the length of the slide? So you just gotta make sure you put your stuff in the right spot. Got the little mama waiting at the bottom of the slide. And my little baby up top. There she go. Oh, I ain't showing you my little baby. Alright. So it says the angle on this one was 46 degrees. What's the name? Faithful. I'm putting 9 feet at the what? You're whispering. I can't hear you. No. Faith, tell me what you think. Don't listen to her. Ain't no long leg. Just say vertical. How about that?
That's the only line I got.
Come on over here, right, Faith? 9 feet. No, honestly, that would be. Honestly, in a triangle, that'd be your altitude. If you're talking about height, that ain't no long leg. Honestly, yeah, this probably be the short leg in this situation. Because this is probably 46 is probably the smallest thing. No, 46 won't be the smallest angle. This will probably be. I'm not drawing this correctly either, so it's not to scale. How about that? Where X going? Hypotenuse, alright. Alright, then we label them H O A. What y'all using? Sine. 46 degrees. 9 over X. Oh, my bad. I ain't know. Why y'all be telling me when I don't show y'all stuff? Y'all know I forget. What you got? 12.5. That you got too? Sweet. 12.5 feet. What's his feet? Yeah, what's his feet?
Wait, so for verifying, can we use triangle for each one?
Huh? Yeah.
Good.
What's the talking for all the other ones? Yeah, it's just the scenarios are just a little bit different each time. Like sometimes you have to make height adjustments. Like on that one, we had to make that height adjustment at the top. First one. This one on the back, we got to make a height adjustment too. You got to understand when you need to make adjustments to your heights. All right. Number 4, it says Reese. Reese, read number 4 since you want to talk so much. Thank you. Alright. So, dog looking up at a cat in a tree. I'm not drawing those out. I'm just going to write those words this time. I can't draw a dog. Got my dog on the ground. Looking up at my cat in a tree. I said the cat climbed 16 feet up in the air. Well, up the tree, you know what I mean. My bad. So, say the cat climbed 16 feet up the tree. Says the dog is standing 5 feet from the base of the tree. They want to know what's the angle of elevation from the point the dog is standing on the ground to the cat. Theta. So we labeling H O A. Go ahead. Tangent. See what tan of theta equals what over what? 16 over 5. Then on this one you should understand that you're missing your angle, so y'all doing inverse. Tan inverse, parentheses, 16 over 5. What you got? Alright. Yeah. 72.6 degrees. These are the word problems, y'all. Y'all just got to figure out how to draw them out. I mean, this is where everything is heading. If you're going to get Trig on the test, it's going to be like this. We might give you the picture, we might not, but honestly, you're going to have to solve a scenario. It ain't just going to be basic Trig. On the back, it's talking about angle of depression. On the front was angle of elevation. On the back, angle of depression. When looking down at an object, the angle of depression is formed by the observer's line of sight and the horizontal line. They show you the situation over here with this lifeguard. He's sitting in the lifeguard chair and he's looking down at a swimmer. The horizontal line plus the angle that he's looking down at the swimmer creates that angle of depression right here. The most important part of this is this second sentence though that they give you right here. And a lot of this stuff should sound familiar because we talked about this before. I told you everything mixes and blends in geometry. It never goes away. Second part says the angle of depression is congruent to the angle of elevation because these angles are alternate interior angles. Y'all should be familiar with those terms. So let me show you what they're saying over here. They're saying this angle of depression right here will be congruent to the swimmer's angle of elevation. If these two are looking eye to eye, then their angles will be congruent to each other because they're both looking down, and their original line of sight will be a horizontal surface. We're both looking kind of at each other. One's looking up, one's looking down. So these are alternate interior angles, and those who've been with me, y'all should recognize these as alternate interior angles as well. So what they're saying is your angle of depression could be congruent to your angle of elevation. All you gotta do, if you got this on the outside, you can move this right inside of a triangle. This first scenario, just like on the front, is already set up for you up here in this drawing. So we really just need to draw the triangle based off this scenario. Same thing. So it says a lifeguard is sitting on a platform. And looking down at a swimmer. I'm not going to try to draw the lifeguard or nothing on this one. I'm going to just draw the triangle situation. In the water. If the lifeguard's line of sight is 8 feet above the water, I mean 8 feet above the ground. So you should know where 8 feet goes. 8 feet goes over here where the lifeguard is sitting. The angle of depression to the swimmer is 18 degrees. So his angle of depression right here is 18 degrees. How far away is the swimmer from the lifeguard? So they want to know the distance from the swimmer to the lifeguard. That variable should be here, x. Only other thing I want you to see is, once again, an angle of depression is congruent to an angle of elevation, and they're alternate interior angles. So if this is 18 degrees right here, I can move this inside right here and call this 18 degrees as well. And if that's the case, now I have it set up so I can do trig. Just need the label. Reese, pick your head up. Hypotenuse, opposite, adjacent. And on this one, if you've been with me, you should realize we're doing tan again. Tan, 18 degrees equals 8 over x. So times x cancels. One more time. 24.6. Somebody corroborating that? Yeah, that's good. Thank you, sir. You moving briskly on this, Earl. Earl, this might be your section, bro. Huh? Thing about it is you came late too. That's what's really crazy, though. Alright, number 6. Sliding on. A pilot in a helicopter spots a landing pad. Imagine this scenario. Below, if the angle of depression is 73 degrees and the horizontal distance to the pad is 1,200 feet, What is the altitude of the helicopter? Y'all have heard this word altitude from me before. Altitude is a height measurement. So you should know where your variable should go even before you draw it out. But drawing it out, I can't draw a helicopter, so I'm going to just draw heli up here, right? Heli. So flying in the air. Helicopter, vertical distance going down. I mean, that way. It's looking at a landing pad in the distance. So this is my LP, my landing pad. This is me creating a triangle. They said the angle of depression was 73 degrees. The other thing they gave you, they said that the horizontal distance to the pad was 1,200 feet. And they want to know the altitude of the helicopter, which is X here. Angle of depression is 73 degrees, so my angle of elevation would be 73 degrees as well. To move that inside. Labeling real quick. Hypotenuse, opposite, adjacent, tangent once again. Tan of 73 degrees equals X over 1,200. You should get a big number because we're multiplying by big numbers. They got a whole number. They did last time.
The zero right there. So I just put zero.
Oh yeah, we just drop all that off. Yeah. Put in your calculator, you should get that. Last one I'm going to do is number 7. I'm not doing number 8 because I feel like you can do it on your own if you need to. You don't have to though. You just go right into the work. But I want to do number 7 because adjustments need to be made on this one. Mine ain't moved on to the next thing unless you're confident unless you got number 7, right? Number 7. Building A is 480 feet tall. Building B is 654 feet tall. If the angle of depression from the top of building B to the top of building A is 42 degrees, how far apart of the two buildings are the buildings? Draw a scenario out once again. You got two buildings standing next to each other. Say building A. They say that building is 480 feet tall. And then you got building B. Put it over here some. These are not drawn to scale once again. Is 654 feet tall. Then they say the angle of depression from building B to the top of building A is 42 degrees. So 42 degrees right here. They say how far apart are the two buildings, so they want to know this distance right here. My variable X goes here. Angle of depression is 42, so my angle of elevation will be 42 inside. I know I'm looking for variable X. Only thing y'all need to understand on this one is another one where adjustment needs to be made. I know this building is 480 feet tall. I know this building is 654 feet tall. But the number I need is this distance from here to here, the top of building A to the top of building B. Somebody got that for me? Yeah. 654 minus 480, which I got. 174 feet. So that's the number I need up there. I need this 174 in here. I write it sideways. 174. Alright, then I need a label. Hypotenuse, opposite, adjacent. For the very sixth time, we are using tangent. Tan again, if you didn't realize. Don't assume everything will be tan, though. It's just a lot of these are tan. Tan of 42 degrees equals my opposite, which is 174, over my adjacent, which is x. And then you need to solve. Give me a sec. Let me set up first. Say it one more time. 193.2. This is feet. Thank you, sir. Bet. Appreciate it. Faith. I'm about to make some adjustments for y'all, just so I can get my work back. Faith. Huh?